More than 60 moons orbit the planet Saturn, but one dwarfs them all. Titan is a colossus, bigger than the planet Mercury. A thick orange haze hides its surface from our telescopes. And when the Cassini mission first peered beneath Titan's orange cloak, it revealed a world weirder than we could have ever imagined.
Titan is an amazing place, and of all the things going on around Saturn, Titan might be the most exciting of all.
Titan has mountains and deserts, rivers and lakes. Only the Earth can match it for geological diversity. But here, water ice takes the place of bedrock, frozen at 300 degrees below zero. And instead of water, the rivers on Titan flow with methane.
This is a place where it actually rains liquid methane, liquid natural gas. This liquid is filling up rivers and lakes.
This makes Titan incredibly special. It's only the second world in the solar system where we know there's liquid on the surface.
And like Earth, Titan has a thick, nitrogen-rich atmosphere. But instead of the oxygen we breathe, Titan's air is spiked with carbon-rich molecules that stain it a dull orange.
It's a soup of methane and ethane and propane and acetylene. The list of organic molecules is literally hundreds long that we've detected there.
Titan's complex cocktail of atmospheric chemicals intrigues scientists, but it also puzzles them, especially methane gas, which rapidly decays in sunlight. So even a billion miles from the sun, Titan's thick haze should have lifted long ago. A vast source of methane must be replenishing the orange smog. Before Cassini, scientists assumed the whole of Titan was covered in massive impact craters. Perhaps crater lakes filled with liquid methane were evaporating into the atmosphere, supplying the missing gas. Cassini carried a hitchhiker all the way to Saturn to help prove this theory. The Huygens lander parachuted through the clouds, snapping photographs as it fell.
As it went through the atmosphere, it took a huge amount of data and then landed on the moon itself and took pictures. When we first saw those pictures, it was life-changing.
There were no craters. It looked like flowing liquid had once shaped the landscape. But at the landing site, and as far as Huygens could see, that liquid was long gone.
Huygens landed in a spot almost identical to what we're standing on right now. If we look all around, we can see this bleak, barren landscape. We see pebbles and cobbles that have been rounded and smooth because they've come through river channels. We see plenty of those at the Huygens landing site. In addition to that, we see lots of sand.
The desert Huygens landed in is huge. It stretches all the way around Titan's equator, with 300-foot-tall dunes sculpted by the wind, just like they are on Earth. If the vast crater lakes weren't at the equator, they had to be at Titan's poles. Cassini scheduled a number of additional flybys to look for any signs of liquid.
One of the instruments on board Cassini is basically a radar gun. It shoots radar waves at Titan, and they get reflected back.
After 2 years of hunting, scientists finally got the signal they were waiting for.
One of the things it found is that near the North Pole of Titan were regions that were not reflecting radar. And that sounds a lot like liquid. Liquid absorbs that energy and doesn't reflect it back. Later observations clinched it.
When Cassini finally imaged the north polar regions of Titan, it finally saw these lakes and seas of methane that we'd been looking for. Only they weren't contained in impact craters like we thought. Instead, they're contained in big lake basins that look just like they do on Earth.
Basin lakes, like this one in Mono County, California, form in the depressions left from tectonic activity. These geological features on Titan could only mean one shocking thing. The moon was alive with geological activity.
If we were sitting on the margins of Kraken Mare, which is the largest sea that we see on Titan, then we would probably see something very similar to this landscape. We would look out across a fairly calm surface. We think the winds are not very strong on Titan, and so we'd have this calm lake of methane and ethane. And in the distance, we would see hills and mountains that have formed on Titan, probably through tectonic processes in much the same way that mountains are built on Earth.
Except on Titan, it's so cold that volcanoes spew water, not lava. And the mountains and lake basins are solid ice. At first, scientists thought that methane evaporating from these lakes generated Titan smog. But when Cassini flew by to measure the lakes again, the levels appeared to be the same. The lakes didn't look like they were evaporating at all. Scientists were stumped. Either the lakes weren't the source of the atmospheric methane, or they were somehow being refilled. Planetary geologist Janie Radabau believes a crucial clue to the missing methane lies in the formation of rocky deposits called tufa. They're found here at Mono Lake, where clean spring water rises up from the ground into the mineral-rich lake, and the two water types react.
This is very exciting because this could be a clue to the missing methane on Titan. So it's rock that has been formed from the chemicals contained in two fluids. There is water that's emerging at the margin of the lake. It's interacting with the lake water, which has a very different chemistry, and all of the chemicals that are dissolved combine with each other and create this rock.
Radar images of Titan's largest lake reveal rocky structures around the margins that look just like Mono Lake's tufa. Titan's tufa, if that's what they are, could be evidence of a layer of liquid methane that sits above Titan's frozen core and rises in springs to feed its lakes, just like spring water rises to feed Mono Lake.
So when those methane springs come in, they interact with the lakes and rock precipitates out. So we see these organic rocks dotting the margins of the lakes. And almost certainly there's also methane just bubbling up and emerging at the margins of the lake as well.
If Janie is right, Titan's lakes do evaporate, feeding the atmospheric smog, but they're constantly replenished by underground methane springs replacing the lost fluid. Titan is no dead world. It's alive with active geology and complex chemistry. And it might be alive with something else, something big.